So the first question was given that there is a dimensionless quantity which is expressed in terms of E, epsilon naught, H and C. So we have the dimension of E is ampere times T, dimension of epsilon naught is this one, H is joule second, so we'll write it directly there, and C is LT to the power minus 1. So we have Q equal to ampere alpha T alpha, this is capital T, time T alpha. Epsilon naught becomes m to the power minus beta, L to the power minus 3 beta, A to the power 2 beta, you can see, and T to the power 4 beta. H is joule second, that is ml T to the power minus 1 whole gamma, and C is L T to the power minus 1 delta. So we will take out the quantities of A, the powers of A alpha plus 2 beta, T, and again what else we get? We get M is minus beta plus gamma, L is minus 3 beta plus gamma plus delta, T is alpha plus 4 beta minus gamma minus delta. Okay, so the option given to us are A 2n minus n. We require to determine the value of alpha, beta, gamma, delta. So option given to 1 minus n minus n minus n, which is clearly from this both will be 0. Alpha equal to minus 2 beta and beta equal to gamma, which is not there. So this is not the correct option. We have n minus n minus 2n minus n. Alpha equal to minus 2 beta. Alpha not equal to minus 2 beta. N minus n, sorry, we have this A will be the correct answer. Alpha equal to minus 2 beta and beta equal to gamma. It is done. So we have the correct answer, 2n minus n minus n minus n. This is the correct answer. This is the correct answer. No more doubt in question. This is one question. Question number 2. Remember, this is done according to the question paper given in the site of the advance. It is saying that an infinitely long wire located on z-axis. First I'm drawing along the, such that this is the z-axis. So carries a current I along plus z direction and produces a magnetic field B. The magnitude of the line integral, so we are required to calculate B dl along minus root 3a along straight line minus root 3a to a0. This is whatever is required. Now we see this is the xy plane where z equal to 0. This is the xy plane where z equal to 0. Let us remove our view to xy plane. This is the xy plane. Now this is the origin. Now we have, this is the magnetic field vector. Okay, this vector is like this because in concentric circle it has same value, and the direction is like this. Direction is like this. You can see this direction will give the upper direction, so this direction is giving the upper direction, so the direction is like this. So this direction can be expressed as this B, this vector field B can be expressed as magnitude of b and in the and define the circle in direction of b. That is, it can be defined as minus y to the power I plus xj by root over x square plus y square. Okay, you can check yourself. When x is 0, when x is 0, when x is 0, the magnitude is minus yi by this one, minus 1. The magnitude is minus 1 when x is 0. When x is 0, y is 1. Magnitude of this is minus 1. When x is 0, y is minus 1. The magnitude is this one. Okay, so this is actual magnetic field. We can explain. Now this b, this magnitude of b is mu naught I by 2 pi r. R is the radial distance. R is the radial distance. So we have minus yi plus xj x square plus y square. We have mu naught I by 2 pi root over x square plus y square into minus yi plus xj root over x square plus y square. We have b equal to mu naught I by 2 pi minus yi plus xj x square plus y square. So finding out the line integral, see one thing, finding out the line integral, finding out the line integral is similar if there was force here, if there was force here and there is dl here. So finding out the line integral is exactly the same as, suppose you are given force. Finding the line integral, how do you make out work? Work is just the line integral of force times delta L along the curve. Suppose the question is to find the work done by a force acting on the curve AB. So line integral of force from this along this curve from A to B is the work done. Now here also similarly we have to integrate this along path. So for work done we can find what, component of 1 into dx plus component of dy f3 dj if f has the component f1 x, f2 y, f3 z, that is f1 I, f2 j, f3 k. If f has the components we can compute the work like this. Same we can do here, same we can do with this line integral. So the line integral value L is given by the curve b dl. b का वैल्यू क्या है, b का वैल्यू म्यू नॉट आई बाई 2 पाई माइनस yi plus xj x square plus y square is the value. Now we are required to find, we can do f1 dx c, that is plus f2 dy, और यहाँ तो z component है नहीं, so we don't need to bother. f1 जो है, f1 क्या होगा, म्यू नॉट आई बाई 2 पाई माइन इंटीग्रेशन ऑफ a जो है, we have to integrate from straight line from minus root 3a to a comma a. Okay, so you have to minus root 3 से a तक, माइनस रूट 3 से a तक माइनस what will be the value of y dx by x square plus y square। और दूसरा क्या होगा बाई 2 पाई जो है a से a x dy by x square plus x। Any integral value from a to a, from a to a, that means it is constant, so it is a 0. Any integral value, this is an integral into variable, but think for here you may think that this is integral into variable, but think for the whole process y is a, so we can do mu naught I by 2 pi minus root 3a से a minus a dx x square plus a square, जो है म्यू नॉट आई बाई 2 पाई होगा माइनस रूट 3a से a जाएगा माइनस a हो गया और यहाँ पे आएगा dx by x square plus a square। So we have mu naught ia by 2 pi और ये जो है tan इनवर्स x by a इंटू 1 by a है इसका वैल्यू। We have a minus root 3a, so this cuts with this minus mu naught I, since in the question it is capital I, we have given, I have also given capital I। tan इनवर्स पहले में a by a that is 1, दूसरे में minus tan इनवर्स minus root 3, so we have minus mu naught I by 2 pi, this is pi by 4 and minus tan inverse minus root 3 is minus of pi by 3, so we have this can be given as 7 mu naught I by 24, so 7 mu naught I by 24, this is minus magnitude is 7 mu naught I by 24, that is option A correct answer according to that question paper given in the site। Now we are going to do question number 3। बोल रहा है कि 2 beads each of charge q, we have 2 beads so we have 2 beads of charge q, suppose these are the beads, one of them is glued, this is suppose this is glued to this bead and this is hoof, and the other is free to move, the other one is free to move, okay, this be r, this be phi, okay, this be r, this be phi, or we can do this as theta, then we have phi equal to theta by 2, you can understand from the geometry, मतलब sorry this be phi equal to theta by 2, phi equal to theta by 2 ले लेंगे, बाद में theta by 2 को पुट करेंगे और अगर नहीं है तो phi ही रखने देंगे, okay। Okay, now what we need to do, now we need to write the equation of motion, you can understand the equation of motion will be in the form torque equal to I alpha, it is of no other form but torque equal to I alpha, torque will be torque equal to I alpha टाइप का होगा माइनस I alpha टाइप का होगा, और उधर से उधर से हमें मिलेगा, सॉरी आई हैव व्हाटएवर रिटन, एफ इक्वल टू माइनस के, सॉरी टॉर्क इक्वल टू माइनस के अल्फा टाइप का होगा, और उसका जो ओमेगा नॉट आएगा वो के बाई आई आएगा, के बाई आई आएगा, उसका जो ओमेगा नॉट आएगा वो के बाई आई आएगा. नाउ you need to identify very carefully whatever you need to identify ये oscillation about which point, ये जब oscillate कर रहा है कौन सा point के about oscillate कर रहा है. ठीक है, देखो यहाँ पे फोर्स लग रहा है F, ये जो डायरेक्शन है ये है F टेंजेंशियल डायरेक्शन और ये है रेडियल डायरेक्शन. Okay, so we will resolve this force along this direction and this direction. Obviously this doesn't contribute to oscillation, only this contributes to oscillation, and we can take the main point to be O, about this point it is oscillating. So first we'll find the force, then we will do the necessary requirement to oscillate about this force, this point. Okay, now this force is equal to, force in tangential direction is equal to k q square by, ये डायरेक्शन ये क्या है, ये r है, ये 2r cos phi है, this one, this is 2r cos phi, easily verify you can, k q square by r square. Now into ये जो कंपोनेंट है sin phi. Okay, then now torque about O is R into F tangential torque about O. ठीक है, we are taking torque about this point, we can take torque about any point, but more for our convenience we are taking torque about this point. So R cross F, so this is capital R, so R k q square by 4 r square cos square phi sin phi. Now this is the torque, ये टॉर्क किस तरफ लग रहा है, नीचे की तरफ. You can see, verify easily, this torque is pointing in downward direction, so you have a minus sign here, so you have a minus sign here, torque equal to के थीटा टाइप होगा, ये के थीटा टाइप होगा, टॉर्क इक्वल टू माइनस के क्यू स्क्वायर बाई 4r cos स्क्वायर फाई और ये साइन फाई हो गया. Now you can, if phi tends to 0, you can understand sin phi is tending to 1, sin phi is tending to 5, sin phi is tending to 5, so we have minus k q square by 4r, and cos phi is tending to 0, this is 5. We have minus k q square by 4 by 16 by epsilon naught r. Now we have taken k equal to theta by 2. कि हमारा कितना, यू कैन सी, जो ये वाला डिस्टेंस है ना, हमें ये वाला चाहिए. देखो अगर कोई ऑसिलेट कर रहा है इसके अबाउट, ये वाला डिस्टेंस, ये वाला एंगल को हम थीटा, ये वाला एंगल को हम थीटा लेते हैं, ये वाला एंगल को थीटा लेते हैं. सो व्हेन आर राइटिंग दिस एंगल मस्ट बी इंक्लूडेड. सो यहाँ पे अगर तुम देखो तो so this angle is to be included. How to include this angle? Now ये जो है ये जो एंगल है, ये जो एंगल है वो उसको थीटा पकड़ते हैं, तो फाई थीटा बाई 2 हो गया. सो ये वाला जो एंगल है इसको अगर थीटा पकड़े तो फाई थीटा बाई 2 हो गया. सो ये है माइनस क्यू स्क्वायर बाई 32 पाई इप्सिलॉन नॉट आर. ठीक है, थीटा 32 pi epsilon naught r into theta, because we are required to take this angle and we have taken this angle. This is phi, this is phi. ये एंगल 180 माइनस थीटा था, ये एंगल 180 माइनस थीटा था. So you can understand this angle was 180 minus theta. एक सेकंड में की थीटा का